Hello and welcome to another episode of Ken Training, where we want to give you, the YouTube audience, the training that you need to tackle jobs like this one on your own. Today's job is, what we're doing is we're in my kitchen right now. Here's the kitchen sink right over here, okay, and then underneath the sink, right over here, is a small little water heater, okay? Let me see if I can give you a good visual on that. But right over here, you can see a small water heater. And what's happening is that this house is 40 years old, and the water from the hot water heater to get to the kitchen sink takes almost 1 to 1.5 minutes before it gets hot, and I cannot wait. I'm a very impatient person. When I want hot water at my kitchen sink, I want it now. So I installed one of these standalone hot water heaters. It's been here for a few years, and now the water is cold. I know that there's something wrong with this, or the unit has flat out failed. We're going to troubleshoot this unit right now. The first thing that we are going to do is I'm going to need to remove these items here so I can gain access to see what the thermostat setting is and if there's something tripped. So I'm going to start with that, and also I can check power because this is electric, 110 volt, so I can make sure that the breaker didn't trip. So two things I'm going to check right away. Alright, first thing I did, because my doors are easily removable, I opened up the cabinet doors, pulled out all of the product, and pulled the unit, the small water heater out slightly. I also have a few tools here. I've got my field piece, I've got a circuit breaker finder, I got a flashlight there. Now, I can see the electrical cord right here. Now, my field piece has what's called NCV, which stands for non-contact voltage. When you take this, press that button in and push the prongs here against the electrical, you can hear it and you can see a visual with the red light that the electricity is on. Also, following the cord here, let me turn the flashlight on so you can see. I can see that we're plugged into the back, and if you see there, hold on, I've got it labeled that it's breaker number 21. So two items are plugged into the receptacle on the right hand side. The top one is the dishwasher, and the bottom one is to our water heater. Here's the dishwasher right here. I got the door closed. You push cancel drain. Hold on. And you can see the light turns on, and I can actually hear the motor. So I know power is going to my dishwasher. Another thing that I'm going to do is I'm going to plug in this tool here, which is an outlet tester. If we get 2 amber lights, we're totally good on the receptacle for the power feeding this. If I wanted to, I could also check voltage, but I don't even think that's going to be necessary. So what I'm going to do, give you a little bit of light here. We're going to unplug our outlet that goes to the, wow, look at that receptacle. The receptacle's in poor shape, I'll tell you that much. Look at the prongs on that. I got to admit, that is a poor looking receptacle. That is not pretty. That looks like it's been overheated. Let's go ahead and plug this in and see what happens. This is interesting. But definitely I should change that receptacle out because it does not look good. Let's see what this says. Now, I'm getting 2 amber lights. You know what? Maybe just, I don't know what. I tell you though, just look at that. That looks a little gnarly. I'll say that much. But let's go ahead and, I can always take this. Hypothetically, if the outlet is the issue, I can always take this and plug it into something else. If I had a concern. Let's go ahead and try that. Okay, so on my countertop, I've got an outlet and I've got an extension cord, 12 gauge extension cord plugged in. Now, not everybody may have one of these, but because I'm a troubleshooter, I have a small extension cord plugged into this extension cord. This is just a homemade tool that I made, where it has no insulation jacket, unlike a standard extension cord. Here the conductors are all exposed, and I've done that so that I can throw my amp probe meter on the white neutral or the green ground. In this case I'm going to just go with the hot black wire. So what we're going to do, I have not touched the thermostat here. Here's your thermostat settings and a red light. Actually, let me just turn this so you can see it a little bit better. Here is the model and serial number of the unit that I'm working on, Ariston. And okay, so let's go ahead and there's the normal thermostat setting. Power's off. I've got it unplugged. I know the unit's colder than cold. Here you can see a pictorial of the red hot discharge and the green cold water inlet. Touching the red hot discharge, it's warm, but it's not hot by any means. Now, what do I want to do? I want to plug this in, and I want to see if my amp meter goes up, telling me that, and plus the light turns on. So just in case the outlet, we're going to just start with power. So in case that incoming power is compromised in any way, we're going to a completely different outlet. So let me go ahead and do that. Ooh, baby, look at that. We're pulling amperage, 11.47 amps. The light is on. By all indication, we are good. So what we're going to do is we're going to let this stay on for a few minutes, but it looks like my problem, from what I'm seeing so far, is going to be that receptacle back there. It looks like I'm going to have to get in there and change that out. It looks gnarly anyways. I should probably change it out just for good measure. So I'm going to start sourcing, see if I have a spare one of those. I might already have one here at the property. And we're going to let this thing go. But it looks like that, in my particular case, was my problem. All right, so then, and I kind of showed you the techniques that I did in order to determine that, just by everything that I showed you. Okay, we got our support staff over here, but they're getting ready to walk away from the project. Okay, so we're still plugged into our water heater. The amperage has gone down to like nothing, as if we're completely satisfied. And let's see here. And the power, oh, it's interesting, the power light's not even on. Oh, maybe because it's not heating, because the thermostat is satisfied. So let's take the thermostat. Okay, first of all, what I should do is alright, so I'm just noting the location that the thermostat is halfway between the ideal and the max. So let's go up to max. Oh, look at that. The light turned on, and the amperage draw came right up. It looks like I'm going to put that back to its original setting, which was the halfway mark, and the thermostat is, the amp drawer has already shut down. We're going to go ahead and run the sink on hot and just see what that, and the water is super hot instantly, which is exactly what I want. I actually do have a spare receptacle, so I am going to go through the steps and change this out right now. Because I've worked on this outlet in the past, I already have my breaker numbers identified, which are breakers 20 and 21. So I'm going to kill those two breakers, get in here and change out the receptacle on the right hand side, because it apparently is compromised, and it would not be a bad idea to change that out right now. So we're going to do that. Okay, here's the electrical panel, breaker panel. We need to shut off breakers 20 and 21, and in my case they are labeled 20 and 21 is labeled disposal and dishwasher. So let's go ahead and shut off this one, 20, 21, but just because it's off here doesn't mean it's actually off. We have to go confirm. The first thing we'll do is we'll just check the garbage disposal, which is this switch right here, and you can see that's off right there. So that's telling me that that one should be off. Now the the dishwasher, when we pushed this before it turned on, pushing it now, nothing's happening. Good. Another indication that we're on the right track. We'll also take my meter here and do an NCV, and we'll go ahead, let me just put put a light on in there. We'll go ahead and do an NCV on the cords coming out of the receptacles there and see if anything lights off. Everything is quiet. Sure looks like we got our power off. Let me go ahead and move this out of the way. Alright, the last thing we'll do is we'll plug in the electrical tester here just to see if we get any amber lights anywhere. And no amber lights there. See if we get any amber lights over here. No, we look like we're going to be safe. So we're just making a mental note that the black cord goes on the one on the left hand side because that's going to be obviously for the garbage disposal. So this is the garbage disposal switch here, and then the other one is going to be the dishwasher and the water heater. Alright, so let me pull off the cover plate and we'll start changing that out. Making sure that the power is off is like the most important thing so you don't get electrocuted during this process here to change out the receptacle. Alright, so I have it opened up a little bit. It's probably the original receptacle. One of the giveaways is the screw here is a flat slotted screw. On the older receptacles, that's how they did it. On the newer receptacles, they have a Phillips head for the screws. Alright, so first of all, I'm going to take my meter, push in the NCV, and just do another final check here. Since I've got some conductors opened up, and we're nice and quiet, which is good, so I can work on this safely. Another thing I'm doing is I'm looking here on the back, and you can see the way that they installed it is that they just put the prongs in and installed it with the push-in prongs. I'm not going to do it that way. Let's see here. Well, on mine, they don't have the push-in prongs. They have this side prong, which is a better connection. This is a much better receptacle. This is probably $4 to $5, and the one that you're looking at over here, that's probably 59 cents. So this is just a higher quality the way that the electrical connection works. So I can't do this while I'm on the camera, so I'm going to hang up with you for now, and I'm going to go ahead and just change it out. Alright, I took the receptacle off, and I want to show you what it is that I see. Hopefully you'll be seeing this. You see that? It's just, the neutral is just like really compromised on the copper. The hot wire isn't quite so bad, and the ground wire looks okay. But what I'm going to do is I'm going to take some emery cloth, which is nothing more than just plumber's sandpaper, and I'm going to scratch that copper and clean that copper. So I'm trying to give you the before and after. So this here is the before, and I'm going to start cleaning it up and spend a few minutes on it right now. Okay, here is your copper all cleaned up. I did all three lines, the ground line, the neutral line, and the hot line. So everything is super shiny, just to give you a good perspective. And now I'm going to go ahead and put the outlet in. When you go to put your outlet in, I'm going to install it this way so that the ground is on the bottom. The brass wire here is where the hot wire or black wire goes. The silver connection is where the neutral or white wire goes, and then the ground gets landed on this green terminal here. So I'm going to go ahead and land my wires and put the receptacle in the junction box. Okay, the new receptacle is in place. I've got a few things plugged in, plus my circuit, my outlet tester. There's the old outlet just sitting right there. Let's go turn breakers 20 and 21 on. Here we are with breaker number 20 and breaker 21. Let's go. Alright, first thing I'll do is check the garbage disposal. We didn't touch the circuit. Oh, did I not plug it in? Maybe I didn't. Alright, you know what? Let's turn the switch on, and maybe I didn't plug it in. No, hold on a second. We are plugged in. Okay, maybe I'm mixed up on something here, but I thought that that was the garbage disposal. The outlet that we're working on here is good. At least the correct 2 amber lights are on, indicating that it's the correct configuration. Now, why isn't that garbage disposal working? I do have it on the right line. Yeah, the black line I can see right there is going towards the garbage disposal. And what's happening here? Did I disturb something back there? I should not have. That's weird. Okay, that's throwing me off. I'll tell you what, let's do this. Let's turn this on and let's unplug my tester. Unplug that. Oh, something happened with the garbage disposal right there. No, that's okay, something. Maybe it just was because I unplugged it and plugged it back in. This outlet must not have the greatest prongs. Alright, so that's good. Let me shut the switch off. Okay, the switch is apparently working. It was just a loose plug. Okay, on the garbage disposal. Let's plug the garbage disposal back in. It actually feels a little sloppy. I don't think it's going to matter which one I'm in because it's the same receptacle. Let's try it down here. Give that a go. Okay, that's fine. I didn't replace the receptacle on the left because I didn't think it was going to be necessary. I just did the one on the right. Okay, let's go ahead and test our heater now by plugging it in. Now, looking at the data nameplate, you'll notice that the unit should pull 12 amps. And if memory serves me correctly, when we did the our test on this line here with the amp probe, it was 11.5, but we'll test that one more time. All right, I have my tester, my testing cord plugged in. I got my meter on amps plugged in, and we're plugged into the heater. We're not pulling any amps. I'm going to go ahead and take the thermostat here, and I'm going to drive that up all the way. And we know that we should not be over 12 amps. We're at 11.73, so we look totally good. Let me just go ahead and put the thermostat back to its original setting, which was about the halfway mark. And let's see if we have shut off. No, we still haven't satisfied, but just for testing, I'll just shut this off all the way. There we go. I could hear it click, and the amps have dropped right off to below to 0. So let me go ahead and put this. Actually, let me leave that off for now. I'm going to unplug my testing cord so I can plug this in directly because we don't need to do any more testing. We're good. So here's the receptacle that we took out. When I went to go take out those prongs, I just use a nail, the neutral and hot conductors. When I go to remove those off of those stab-in connections, I just take a nail, I depress it in this section of the outlet right here, and then that depresses the pins to allow the neutral and hot conductors to come out of these landing points on the receptacle. So that's how I got out the old conductors so that I could reuse them. Then just cleaned them up with the emery cloth as you saw, and then put everything back together. So this job is all buttoned back up and all back to normal. Okay, that is going to conclude this video. I hope I gave you some tips on, just in case you needed to troubleshoot your own water heater, electric water heater in your own case. In my case, it just happened to be electrical. Now, of course, had it not been the receptacle, I would continue on with my troubleshooting techniques all the way to the heater itself, and to the point where I would replace the heater if that was necessary. And actually, going into the project, before I started the troubleshooting, I thought that's the direction that, I thought that is what was going to need to be done in order to solve the problem. But through the troubleshooting, obviously not. We have the hot water, we're good to go. That's it. Go ahead and smash that like button down. Subscribe to my channel, Ken Training. Leave a comment about what you thought of this video and your projects. I will catch you on the flip side.